Hi guys, welcome back to another IBHL math tutorial. Here we're going to look at integration, specifically a shortcut method which can be used to solve substitution sums much faster. IB Math HL is a very time intensive subject, and thus you should be looking at ways to shave off time of these simpler sums such that you can focus your attention on the much harder ones. These steps usually don't account for any step marks as it's usually part of a much larger sum, so it makes a lot of sense to skip the working here. Nevertheless, this shortcut can only be used under certain conditions, which we'll look at later. So first, let's look at how we would usually solve this substitution problem so that we can understand how the shortcut actually works. So in substitution sums, we obviously have to substitute a variable into the original equation so that we can make the integration process possible. So when deciding what to substitute in, this is usually a hassle. So yeah, the shortcut can help you save time here. But when deciding, we have to think about what can I substitute such that after the substitution process, there are no x terms left in the integration equation. So I would take u is equal to x cubed minus 4, and then now I will differentiate it. So du by dx is equal to 3x squared. Then make dx the subject because we want to substitute dx back into the original equation. So we would get dx is equal to du by 3x squared. Now we can substitute this back into the original equation. We would get integral of 3x squared by, and since x cubed minus 4 is equal to u, we could just write u here into du by 3x squared. So we can cancel this and we get 1 by u du. So the fact that there are no more x terms left in this equation here shows us that our substitution process was correct. So when you learn basic differentiation, you probably learned that d by dx of a natural logarithm of x is equal to 1 by x. So this is a basic rule that we usually learn when learning differentiation initially. So if you want to find the integral of 1 by x, well, so we can basically derive this. So the same way, these two are in the same form. We can write this as ln u plus c. Now we have to substitute u back in, and we get x cubed minus 4 plus c. So this is the correct solution. As you can see, this did take a little bit of time, and I would say spending this time on a very simple sum like this is quite useless because it's most likely part of a much larger sum. So now that you know how the substitution process works, let's look at the shortcut. Basically, to use the shortcut, we just have to remember this one condition. So if any integral is in this form, well, you can just straight away find the solution. So let's look at this integral here. If we take f of x is equal to x cubed minus 4, what would f dash of x be? Well, 3x squared. And now look at the numerator. Well, the numerator is basically f dash of x. So it satisfies this condition. So the solution would be the logarithm of x cubed minus 4 plus c. So basically, you don't have to write this situation out, but then if you just look out for this condition in an equation, well, you can solve it super fast. Most of the time, the actual differentiation process here to find out f dash of x is super simple, and therefore, yeah, you could probably just do it in your head. This shortcut is also used to solve the integral of tan x. I've made a separate video for this, so I would strongly recommend you to watch that video because this shortcut is being used in a slightly different way so that, to learn the nuances of this shortcut, that video is strongly recommended. So hopefully by using this shortcut, you can save a lot of time in your paper. Thank you for watching.